Okay, let's see. Last class, I think we did these vector problems. 2.21. Let's see. We can continue with some more topics here to make sure that your basics are thorough. Position vector, these things we already discussed, right? Position vector, differential calculus introduction, integral calculus. 2.21, I think we already discussed this. Okay, let's try 2.22. So they are given it in the ijk form, velocities, and they are asking you to find which particle travels with the greatest speed. So that means basically we have to find the magnitude. If you know how to find the magnitude, it's a very easy problem. So as I said, each one try to calculate the magnitude and it's still easy. Square root of 3 square plus minus 5 the whole square plus 2 square. So it will be 9 plus 25 plus 4. So that will become 29 plus 9 root of 38. So approximately 6 point something, right? 36, root of 36 is 6, so 6 point something. Similarly do it for VB. Root of 1 square plus 2 square plus 3 square. That will give me 1 plus 4 plus 9, so 14. This will be VC. Y squared plus 3 squared plus 4 squared. So 25 plus 9. 25 plus 9 plus 16. 16 plus 9, 25, 25 plus 25, root of 50. So obviously VC looks the largest, right? So the greatest speed will be having VC will be, C particle will have the highest speed. Any doubt, anybody? Very easy. Two cars are traveling with respective velocities. V1 along east. So that means this is going towards east. And V2, so this is velocity V1. And this is along V2 towards west. What are the speeds of the car? So speed is going to be just the magnitude. So that means both are 10 meter per second only. Right? No change. Only the velocity is different. Speeds are same magnitude. Then they are introducing you about the concept of momentum. I'm sure you have been introduced a little bit in your 9th standard or 10th standard. So mass into velocity is your momentum, right? Or linear momentum. So if I want, and that is also vector quantity because v is a vector, that means momentum is also vector. And this p is small p, not capital P. Capital P means pressure. So this is small p. Okay, so you should not confuse this with pressure. And then in the ijk form, you will have something like this, which means you will write it as mvx, mvy, mvz. And we call that as x component, y component, z component. Okay, so nothing very difficult there. So mass into velocity is your momentum. Consider two masses moving at the same speed, calculate the magnitude of the momentum. So that means P is equal to mass into velocity, or magnitude means just simply mass into velocity or speed. Mass is 10 gram, so 10 gram divided by 1000 to convert it to kilograms. Velocity is 10 meter per second. So this I will cut as P1, so 1 by 10. Units will be kg for mass, velocity is meter per second. So that's the units. P2 is equal to m2 v2, m1 v1, m2 v2. m2 is 1 kg, v2 is again 10 meter per second. That means it will be 10 kg meter per second. Okay. So what it means is forces related to momentum, right? Rate of change of momentum. When a cricket ball is coming at you, it may be like very small mass, maybe like 200 grams, 20 grams, something like that. Whereas the velocity might be very high. Whereas if a car is moving, even if the car speed is less, the kg, the mass of the car is 1000 kg, which means the momentum will be very high. Okay, so 1000 kg is coming at you. Even if the speed is very low, the momentum will be very, very high. Any doubts? Can I move on? If you raise any doubts, I can answer it. Otherwise, I'm going to assume that you're following everything. So if you have doubts, please raise your doubts. Okay. Prasanna Devi, late ஆகுறீங்க ரெகுலராக 10 o'clock கிளியராக வந்துருங்க ஓகேவா motion along one dimension, average velocity. எல்லாமே mostly maths mathematics average velocity so you don't have to worry too much. If you know the basic mathematics, you can do it. But maths, I don't know how much they have taught you the differentiation integration. So in the concept வேணா நம்ம படிக்கலாம். We can talk about this. So velocity is equal to dx by dt. Similarly, acceleration is equal to dv by dt. So x is your displacement. So dt can come here. So dx is equal to v dot dt. So if I want to integrate, I can integrate it on both sides. So this will be your x1, this will be your x2, right? So x2 minus x1 is equal to integral of dv by dt. That's how you will get v is equal to u plus at. So if you integrate this, you will be integrating from t is equal to 0 to t is equal to t. So if I integrate this, I will get ut plus a t square divided by 2. A is a constant for uniform motion. Sorry, uniform acceleration. A is constant. So if I substitute t is equal to 0 to t is equal to t, lower limit and upper limit. When I substitute this, I will get ut plus half at square. The lower limit will become 0, so we don't have to worry about it. So that's your x2 minus x1. This is what you must have said as s is equal to ut plus half at square. And sometimes this x1 can come here. So this x1 is called the initial displacement. Okay. So sometimes the same formula you may have seen it as s is equal to s naught plus ut plus half at square. I'm not sure what is there in your book, but this is very often you will be using this concepts. Okay, so that's your integration from here. So same thing you can do it for acceleration. Let's see what they have done here. So the area under velocity time graph will represent the distance covered or displacement. You see on this side we call it as positive displacement. Here we call it as negative displacement. Okay, so this minus this it will give me the net displacement. Again, if it is slightly confusing, don't worry about it. Okay, as we do some problems, you will understand it's just simple mathematics. And average velocity is displacement by time taken. x2 minus x1 is your displacement divided by time taken. t2 minus t1. Any questions, doubts? A particle moves along x-axis in such a way that its coordinates x varies with time t according to the equation x is equal to this much. What is the initial velocity of the particle? Initial velocity means when time t is equal to 0. Time t is equal to 0, what is v? So what I can do is velocity means dx by dt. So that means you can differentiate this. So x is equal to 2 minus 5t plus 6t square. If I want velocity, I should differentiate this. So dx by dt. Differentiating 2 will become 0 minus 5 plus 12t. As I said, initial velocity means time t is equal to 0. So that means I have to substitute. So v of v when t is equal to 0 is equal to minus 5 plus 12 into 0, which means it is minus 5 meter per second. So that means the velocity is on the negative direction. Instead of going in the positive x-axis, They are going in the negative x-axis. That's the meaning of it. Yeah, you see, initial velocity is minus v. Negative sign shows that you are moving in the negative x direction. Average speed is defined as total distance covered divided by total time taken. Okay, so total distance covered, total path length. Relative velocity is an important concept, right? Velocity of A with respect to velocity of B is VAB is equal to VA minus VB. Similarly, relative velocity of B with respect to A is VBA is equal to VB minus VA. It's a easy concept. Yeah, they are given a nice picture here. So let's assume that you are going in this car and your friend is going in this car. Okay. So if you follow the example, I'm sure you will understand the concept very easy. Two cars with respect to ground along parallel tracks and in the same direction at velocities of A and B is 35 km per hour and 40 km. So that means this is 40 km per hour. This is 35 km per hour. Due east. Due east. So both of them are going towards east. What is the relative velocity of car B with respect to car A? So that means with respect to a person standing in the ground, listen carefully, very important. So if somebody is standing in the ground, this guy is going at a speed of 40 km per hour. But for a person who is going in 35 km per hour, right? So with respect to this guy, he is going only at a 5 km per hour because 40 minus 35. Okay, how to do it in the formula? Velocity of B with respect to A is equal to velocity of B minus velocity of A. Velocity of B is 40 minus 35. So that means it will be 5. That's all. Okay. In this problem, they are not asked you about the relative velocity of A with respect to B. But if they have asked it, then you would be doing velocity of A with respect to B is velocity of A minus velocity of B. Velocity of A is 35. Velocity of B is 40. Then 35 minus 40 it will be minus 5 km per hour. So what is the meaning of this? Plus 5 means B is ahead of A 5 kilometers for every 1 hour. Whereas A is behind B. That's the meaning of this. So A is behind B, and that's what the negative represents. Okay. Sometimes the cars might be going in the opposite direction. Then it will get added up. So we'll see if they have given that example. Otherwise, yeah, you see case 2, they are given A and BB are in the opposite direction. Maybe I can explain that. They are not shown an example. So let's say this is going at 35 km per hour. This is car A. And car B, let's say it's coming this way now in the opposite direction. So that means it is 40 km per hour. Now the problem will slightly change. Okay, the answers will slightly change. Why? Because now they are approaching each other, which means they are not moving in the same direction. So velocity of A with respect to B is equal to velocity of A minus velocity of B. Velocity of A is 35 minus velocity of B is now, if you have taken this as positive direction, this should be taken as negative direction. Why? Because velocity is as vector. That means you have to put minus 40. You cannot put plus 40 like what we did in the previous problem. So 35 plus 40. So it will be 75 km per hour. So what it means is the relative velocity is higher, or they are approaching each other. Similarly, B with respect to A would be VB minus VA. VB is minus 40. VA is plus 35. So minus into plus, it will be minus, so it will become minus 75. Okay. What this means is B is moving away in the negative x direction, whereas A is moving away from B positive x direction. Any doubts here? Okay, if you don't have any doubts, we'll keep moving. Velocity of A and B need not be in straight line. It can be in two dimension, like angle between them. In that case, what will happen to the change in velocity, right? So that is what is given here. They are not shown the diagram, unfortunately. So diagram is more important. So suppose if I have a velocity of A here, this is velocity A, this is O, this is A, say this is velocity of B. Okay. Imagine that one car is going in this direction, another car is going in this direction. So now if somebody asks you what is the relative velocity between B with respect to A, then it will be, this is your final minus initial. So VB, yeah. So VBA is equal to velocity of VB minus VA. Okay, so take it down properly. The diagram is not given in your book. Only if you have diagram, this will make sense. The entire discussion will make sense. VB minus VA. So this is like vector subtraction. So vector subtraction, it's slightly different from the vector addition formula. Okay. So VB minus VA magnitude is equal to VB square plus VA square. Instead of plus, it will be minus. Minus 2 times AB. So VB into VA. And then it will be cos theta. So theta is the angle between A and B. Then don't forget the square root. So this you must have studied in the vector addition. A square plus B square plus 2AB cos theta. So it's the same thing, only you will get a minus. Similarly, the angle between A and B, this angle will be tan alpha with respect to the first vector. Tan alpha is equal to B sin theta. The formula I remember is B sin theta divided by A minus B cos theta. So I will write this as VB, VA, VB. Okay, so if you remember the original formula, I think I talked about vector addition some time back. Okay, vector addition, vector subtraction, go back and study that. So check the formula. Yeah. VB sin theta, VA minus VB. Beta is the angle between VAB and VB. Why did they say VB? It should be actually VA. Okay, maybe they are taken. Not shown the diagram properly. So I thought alpha is the angle between A and this VBA. Okay, we will double check that. Okay, as we do some problems, probably we will get an idea. Very often you will get this umbrella and rain problem. Okay. Okay, let's see. Okay, there is a nice diagram shown here. Maybe I can copy this picture also. Suppose two trains A and B are moving with uniform velocities along parallel tracks. Oh, okay, so it's not related to this umbrella problem. Okay, I thought it was related to this umbrella problem. Okay, let's see if we can discuss this umbrella problem first. So this is the rain is falling vertically downwards, right? So we call this as VR. And then the velocity of the man is he is walking in the horizontal direction. So if I hold the umbrella straight like this, I will get wet. So what we do is we try to tilt the umbrella. Why? Because even though the rain is falling down like this, because of this velocity, there will be a relative velocity of rain with respect to the man. Okay, so this we are going to call it as velocity of rain with respect to the man, which means velocity of rain minus velocity of man. Okay, so velocity of rain man will be this way. Velocity of rain is this way, vector. So velocity of rain with respect to man, it will be like this. So this will be your VR with respect to m. Okay, because remember I told you it is like vector subtraction. I don't know why they are confused you like this. Actually, it should come like this only. Because vector subtraction means you have to connect these two things. This is vector addition. So here you will not do vector addition, you will be doing vector subtraction. So since it is nothing but your Pythagoras theorem, you can do Vrm is nothing but Vr square plus Vm square square root. Okay, so that's your magnitude. And if I want the angle, you can use your tan theta formula. Let's see what they have done in your book. Yeah, you can use tan theta. So this is nothing but your Vr minus Vm. Velocity of rain with respect to velocity of man. Okay. So if I go back and apply the formula which we studied here, you will get the same thing. So Vr squared plus Vm squared. If you want, I can expand this formula minus 2 times Vr Vm cos theta. Cos, this will be the angle between the two vectors. So it will be cos 90. Cos 90 is, it is 0. So that's why this term goes away. So that's why we did not write this term. Similarly, your angle formula, if I want to find the angle alpha, I can say tan alpha is equal to opposite by adjacent. So that means I can write as VR by Vn. Okay, so we can do this math and you can find the alpha angle. VR sin 90, so VA is Vm minus this one will be yeah. So yeah, so actually this is with respect to angle A only. So, any doubts here? I think very easy, right? So very often they'll ask you this umbrella problem in the rain. Instead of walking man, sometimes they will give you a somebody is riding in a bicycle and then holding an umbrella. So what this means is they have to tilt the umbrella with certain angle alpha with respect to the horizontal. Okay. Or sometimes if they ask you this angle, then you have to do 90 minus alpha to find this one. Okay, so nothing very difficult if you know the simple mathematics. Okay, now we can go to this train problem. Suppose two trains A and B are moving with uniform velocities along parallel tracks but in opposite direction. So that means parallel tracks but in the opposite direction. So that means one train is going here, let's call this as A, another train is going here, let's call it as B. Let the velocity of train A is 40 km per hour. Velocity of due east, so that means it's going in the east, and this is due west, so 40 km per hour. Calculate the relative velocities of the trains. So I think we already did this. So the relative velocity of A with respect to B is equal to VA minus VB. VA is plus 40. VB is minus 40. Which means this will become 80 km per hour. Similarly, VB with respect to A will be VB minus VA. VB is minus 40. Minus 40. So what this means is A is moving in the positive direction, B is moving in the negative direction. That's the meaning of this. So they are given nice examples in your book. So if you do the examples, I'm sure you will understand it. And relative velocity, relative displacement, all these things might be slightly confusing initially, right? So take some effort, and if you have doubts, ask me. We can discuss that further. Go through this and try this. We'll get some water. Consider two trains A and B moving along parallel tracks with the same velocity in the same direction. So that means train A and train B, same direction, same velocity. With the velocity of each train B 50 km per hour. So velocity of A is equal to 50 km per hour. Velocity of B is equal to 50 km per hour. Due is to calculate the relative velocities of the train. Very simple. Relative velocity is 0. Whenever both the speeds are same, velocity of A with respect to B will become velocity of A minus velocity of B. So that means there is no relative velocity. So that's why when you have another train going parallel to yours, you will feel that both the trains are stopped. Okay, even though both of you are going at a high speed, if the situation happens, right, you will feel that the other train is not moving because of this effect. And that's why if the train is going in the opposite direction, it will feel like you are going at a higher speed. Why? Because the relative velocity will become higher. 50 minus of minus 50, it will become 100. Okay, my computer is being a little bit slow, so bear with me for a second. Yeah. How long will a boy sitting near the window of a train traveling at 36 km per hour see a train passing by in the opposite direction with the speed of 18 km per hour? The length of the slow moving train is 90 meter. Okay, let's try to do this problem. So somebody is sitting the window here and you are moving with the speed of 36 km per hour. Okay. So 36 km per hour means I think it will be 10 meter per second. You can do the conversion yourself, right? Multiply by 1000 divided by 3600. So I think it will become 10 meter per second. The length of the slow moving train passing in the opposite direction. How long will a boy sitting near the window? So that means as the train is passing, how long will I see the train? That's the question. And this is 18 km per hour. 18 kilometers, half of this, which means 5 meter per second. So what this means is the simple concept is, and the length is given as 90 meter. So the simple concept is, the distance of the train is 90 meters. So velocity is equal to distance by time. Distance is given as 90 meters, no doubt. Okay, very important problem, so listen carefully. 90 meter. Time is what is asked. They are asking me to find time. If I was sitting here on a stationary platform, then I would have directly taken this as 18. So then it will be 18 is equal to 90 divided by t. So t is equal to 90 divided by 18 or 5 meter per second, right? Velocity is equal to 5 meter per second. So let me write it one more time here. So it would have taken 18 seconds for me to see this train crossing me, provided I was sitting in a stationary platform. However, right now I am not sitting in a stationary platform. I am sitting in a train which is also moving at 36 km per hour. That means the velocity here, I should not take it as 18. I should take the relative velocity between this and this. The relative velocity will be 36 minus 18. So that means it will be 54 something, right? Or you can say 10 minus of minus, so it will become plus, so 10, 15. Everyone following what I'm saying? So you should not take the direct velocity here, I should take the relative velocity because it will be the train will move out of me very quickly because I'm also moving in this direction. So if you get that idea, it's very easy. So velocity of B with respect to A. Let's call this as B and this as A. So velocity of B with respect to A is equal to velocity of B minus velocity of A. Velocity of B is minus 5. A is plus 10, which means it will be minus 5 minus 10, so it will be minus 15. So that means the time t is equal to d by v, which means, as I said, it will be the relative velocity vab or vba. But generally in this formula we will not take the minus because time cannot be minus. So d is 90 meters divided by this is 15 meter per second. So do the cancellation. So I think I will get 18 divided by 3. Right, so it will be 6. So which means if I was sitting in the platform, then it will take 18 seconds for the train to cross me. But since now I am moving in this opposite direction, it will take less time because within 6 seconds the train will cross me. Okay, I'm sure all of you must have experienced this when you are traveling in train. Okay, so nothing very difficult here. If you have any doubts, please raise your doubt. So let's see how they are done it here. Yeah, so t is equal to 90 by 15. For your understanding, I have shown the stationary situation, and you can see this is boy sitting stationary. This is we are going in a train. Boy traveling in another train. It's also very simple. Okay, so you just have to use the relative velocity. The same thing they can change the question by moving in the same direction also. In that case, it will take longer time. Okay, so for the train to cross, it may actually take more time because what will happen is it will become 10 minus 5, so it will become 5. So in that case, it will be 90 divided by 5, so it will take 18 seconds if you are going in the opposite direction. Sorry, if you are going in the same direction. Okay, this river kind of problems very often they'll ask you. Okay, especially in NEET and JEE, they'll ask you these kind of questions. Okay, swimmer's speed in the direction of flow of a river is 12 km per hour. The direction of flow of river is 12 km per hour. Against the direction of the flow of the river, the swimmer's speed is 6 km per hour. So against the direction of flow of the river, swimmer is able to go only at 6 km per hour. Calculate the swimmer's speed in still water and the velocity of the river flow. So that means you have some river here, then there is a swimmer swimming, right? Something like that. Or you can try to show like this. Okay, doesn't matter. So if velocity of river is Vr and velocity of the swimmer is Vs, in this case both are in the same direction, which means both will get added up because the river will try to push the person, so it will become easy for the person to swim or move. So that means swimmer speed Vr plus Vs is equal to 12 km per hour. Against the direction of flow of river means Vr minus Vs, because now you are going in the opposite direction. So the river is going in the forward direction, but you are going in the opposite direction. So we are here, Vs here, and that is given as 6 km per hour. They are asking you to find Vr and Vs, that's all. So simplify this, you will get the answer. Added, these two will cancel. So 2 times Vr is equal to 18. So Vr is equal to 9 km per hour. If I substitute it here, 9 minus Vs, or you can take the first equation, 9 plus Vs is equal to 12. So Vs is equal to 12 minus 9, so it will be 3 km per hour. Okay, so very easy. If you understand that it is Vr and Vs in the same direction, opposite direction. Very easy. Any doubts? Yeah, so we are Vs. Why are they getting the other way around? Hmm. VR is supposed to be higher. Vs should be less, right? You cannot swim. Did I make any mistake here? River and swimmer. VR. 2 times VR is correct. 18 is correct. VR is 9 is correct. So 9 plus Vs is equal to 12. So Vs plus if the swimmer is 3 km per hour. Well, I think I made a small mistake here. Only if your speed is more than the river speed, you will be able to go, right? Otherwise, you will not be able to make any progress at all. So that means the Vs has to be bigger and VR should be smaller. Only then you will be able to go forward. So that means I would redo this problem. So Vs plus VR is equal to 12. Vs minus VR is equal to 6 because this has to be bigger. The swimmer has to be faster than the river. Only then you can move forward. Otherwise, river will keep on pushing you backwards. That's all. So you do this correction, you will get the correct answer. So 2 times Vs is equal to 18. So Vs is actually 9 km per hour. Vr will be 3 km per hour. Okay, so I made a small mistake here. Okay, I think accelerated motion, average acceleration very similar to average velocity in instantaneous velocity, right? So maybe we can continue this in the next class. Again, the purpose of the class is make sure that you folks are comfortable with the basics. Only if you know the basics, you will be able to do the later chapters thoroughly, confidently. Okay, so I think we have done some good progress with the basics. So we are doing somewhere around 30, yeah, 29, 30. So we are done up to 30 questions. So maybe in one more class, probably we can complete this chapter, I think, I hope. Yeah, I think after this mostly 36. Oh, then you have projectile motion also. Okay. To this it is one chapter and then projectile motion, it's a little bit longer. And then you have the circular motion. I hope, yeah. Okay, so people who are finding, if you're not able to follow things in school, at least here you should attend classes regularly. Okay. Okay, thank you all. If you have any doubts, you can ask me. Otherwise, you are free to go. Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.